part. So here, given an m cross n both variation in the words which is being given to us. So here we are given with this matrix, right? You can say substring, which is not the substring, but the right word which is being present in our matrix. So that's the thing which we are going to do in this particular. So doing that method means just doing the DFS for the 10 raised to power 4 words. That would be really a huge number, right? In context of time. So in that context, let us perceive that there are various words which could be having the same prefixes. And with same prefix, if a particular word is not present in the matrix, then so as per the prefixes, we can sort all the words and such, not sort, but we can club those words with the common prefix and till whatever point it is having the common prefix. And after that, we can branch out the other words and just select that which word is the requirement of our input which is being given to us. So according to that only, we will be going ahead and as per the constraint, doing only DFS plus the backtracking will give us TLE, right? So thus we need some data structure as per the above observation, means as per this particular prefix. Prefer data structure number of words which is being given to us because number of words here would be up to 26. That's for sure because here 26 are the maximum try means maximum try notes not notes. Time complexity is reduced from that 10 raised to power 4 to 26 in context of number of words, but now it is dependent upon length of the word. That's for sure. So now comes the part that how we are this particular question. So first thing is that we will be creating a try for an input word, then do DFS in the grid given while comparing each character with strings stored in the try. So that's the thing which we will be doing in the same next part, that how we are required to code the tribe. So for creating the class for the tribe, as usual means as per you can say means in most of the cases what I note because we are storing all the words and we are going to do here is we are taking one member as string word and taking one member as vector whose data type children is its name. And this is the constructor of this particular class. Here what we are doing is we are basically assigning 26 memory blocks to this particular children vector and initializing it with null. So that's the thing which we are doing here for this particular try node. And now comes the part that while using in our this particular function which is being given to us, the first thing is for using that try node, we require object. And by doing this, we are creating an object of try node class. And then first thing which we will be doing is why we use this try. Basically, we used this try to store all the input words which are being given to us, means all the input words here which are being given to us, we will be storing them in the try. Means rather than comparing directly with this vector of string which is being given to us, now we will be storing these words by clubbing them as per their common prefixes in our try and then doing the DFS for the same. So that's why we will be having this function build try where we will be passing this word so that all the words which are being present in this words that will be now add up in the try and this is where our try would be stored. And here we will be storing an answer. And then here what we are doing is we are doing basically DFS. How we are doing this DFS is we will be passing the board which is being there because we are performing DFS on this particular board. And at each point for each character, we are comparing to the try node which is being given to us. So that's the thing which we will be doing. Now let us go ahead by for the insertion of our nodes in this try. So the first thing which we are doing here is we are first going ahead. See, here we are having this root and then we are allocating the memory in the try node data type. Now in this particular thing, what we are doing is that whatever word which is being given to us means that vector of string. As per the length of that, we are first extracting the first word which is being given to us there, and then starting from the root point, then we are checking for that word which we have just recently stored and particular. words which is being given to us, right? Then this first word which is there, that we are storing here. Now this try node current equals to this particular words which is there, we are going up till its length, means basically traversing this vector of string which is being given to us, and we are taking this word here, and then what we are doing is that here we are basically checking in the start which is there. So let us first take this oath. So oath will be 15th because O is 15. So here we will be having null pointer because at the starting we have initialized with null, right? So these are the all directions which are there. What the things which we are doing here. So reconciliation would be as it is, that going in all four directions, that the subtraction or addition which we are doing, so they are not making them out of the boundary. So that's what we are doing in this particular, means changing the position of our key. So here, character while doing the DFS, and now comes the part. So the time complexity for the same is m into n, because we are doing DFS over the matrix of n cross n, into 3 raised to power L. Now why 3 raised to power L? L is basically the length of the longest string which is there. So M into N is basically length width of the matrix, and L is the length of the word. That is, when we traverse, then we could go in 3 direction only when we are inside a word each time. And how 3 direction? You can clearly where the longest length would be there for our L, which is there, means basically longest length of a particular word, into 26, right? So that's why it is the space complexity is on the basis of 26 into L. And about the recursive stack, so in the recursive stack as well, whatever at max we